Hi, my name is Russ Johnson, and I'm going to be talking about SIP signaling in a Cisco environment. I'm with Colorado State University, enrolled in class CIS-620, and I'm going to be talking about SIP. SIP stands for Session Initiation Protocol. Is basically a signaling protocol that is used to set up sessions for voice, video, and even messaging type of applications. Defined as more of a protocol to provide two endpoints with the ability to set up, establish, and tear down multimedia voice calls. But its predominant uses are for voice and video and messaging. It was first developed in 1996 by a couple guys, Henning Scholzering and Mark Handley, and they got together and worked on it and turned it into an actual published RFC through the IETF, which is Internet Engineering Task Force. That's the governing body that comes up with all the standards that we use for most of our internet protocols that we know today. So it came out of the internet community, the IP community. SIP version 2 was revised in 2002, and that's the standard that's still in use today. So they have been working on it and tweaking it. I'm sure they'll come out with a new standard at some point as they kind of fine-tune the protocol, as they do with any protocol. So I talked about SIP has its roots in the IP community coming out of the IETF. So as a result, it employs a number of design characteristics that are similar to HTTP and SMTP, two very popular web-based protocols that we use for web pages and email. SIP is a peer-to-peer protocol. However, in practice, there are a number of servers that we'll go into later, and it does have a little bit of a client-server relationship, but it's generally known as a peer-to-peer protocol where endpoints are intelligent and they don't necessarily need a centralized call server to be able to function. So the intelligence and the call routing ability or session routing capabilities are kind of baked into each SIP endpoint, whether that be a phone or a video conference device or a messenger type of application. It's an application layer protocol. SIP signaling generally runs on TCP or UDP port 5060 or 5061. 5060 is used generally for the clear text, non-encrypted type of signaling communication. 5061 is used for the encrypted signaling communication if you choose to set that up in your environment. That runs on TLS, transport layer security. Voice and video streams are actually delivered via another protocol, RTP, real-time transfer protocol, and that's the pretty standard protocol that all voice over IP and video calls tend to, the media streams actually get delivered over that protocol. So in SIP, within SIP, there's also another protocol called SDP, which is used to set up and negotiate the RTP port numbers that the SIP session will end up using to send the media stream back and forth, and also what protocols and codecs, audio codecs, will be negotiated to make the call. So let's talk about SIP elements. SIP has user agent elements and server elements. So I talked a little bit about how in practice SIP can be employ a little bit of client server and peer-to-peer. In a SIP setup, you'll have user agent clients that send SIP requests and user agent servers that receive and send responses to SIP requests. And a SIP endpoint, like a IP phone, can act as both a user agent server and user agent client. Then when we talk about the server elements in a SIP design, there are proxy servers, registrar servers, and redirect servers. These servers all serve some different types of functions. I can tell you in a Cisco environment currently, if you're running one of the newer versions of the Unified Communications Manager, all of three of those servers are combined and baked into the call manager. So it kind of does all of those in one. SIP addressing. SIP uses a URI, Uniform Resource Identifier, which is also used in SMTP. So it looks very similar to an email address. It will have SIP : in front of it, but then you'll have a user ID at domain.com, very similar to an email address. So, you could have a SIP username of, with a name at mydomain.com, or you can have an EI 164 address, which is basically a telephone number. So you could have SIP telephone number at a domain.com. And those are the standard addresses that SIP uses. So the SIP protocol itself has a number of request messages that the client would be sending to the server. So a few of the popular ones: invite. Indicates a client is being invited to participate in a call session. It could also send a bye, terminates the call. So there's bye, cancel, options, register, prac, subscribe, notify, publish, info, refer, message, and update. And I'm not going to go into all of them, but there are a number of request messages that could be sent by a client to initiate or modify or terminate or change or add features into an existing SIP session or voice call or video call. So you have the request messages and you have the response messages. The response messages, there's a lot of them, so I'm not going to go into all of them, but they're categorized into these 6 type of categories here: provisional, success, redirection, client error, server error, global failure. So when you're debugging or troubleshooting a SIP session or SIP call, and you get to pull out some of the debug messages, they're all going to look they're in clear text. They're going to look a lot like HTTP and some of those messages, and so they're going to be text-based. You'll be able to read them, and you'll be able to tell what type of response was given. So if it sent out an invite message to establish a call, and everything was good, then you might receive a success message with with some other code here back to the server, and you would be able to see those in all the debugs. So SIP endpoint communication. Here's a quick diagram of kind of how it works. Basically, you have a SIP phone A, SIP phone B. When you pick up and dial, SIP phone A sends an invite message to B. B will start ringing, and it sends a 180 ringing message back to A, and then also once it answers the phone here, it sends a 200, remember that was success, and sends that back to phone A. Phone A then acknowledges it, and then use that SDP protocol to negotiate the voice RTP ports that will be used for the communication stream. And also the codec that will be used, G711 or G729 are popular ones. And so then they'll be on the call, and then when whoever decides to hang up the phone, let's say user B hangs up, sends a bye request back to A, A sends a success message back to B indicating, okay, it hung up too. So that's a basic SIP call. In Cisco's VoIP communication environment, so a Cisco environment where you have IP phones. This is kind of a diagram that explains a little bit about how it works. So we have a gateway that's connected to the PSTN, Public Switch Telephone Network. So your carrier like CenturyLink or whoever you get your phone lines from. And you have your call manager cluster there, and your 2 IP phones. So in this example here, The phones can actually send their signaling information back to the call manager, and the call manager is kind of the facilitator between the two phones. And then once they establish a call, there will be a physical IP connection via a switch there that the phones are plugged into, or if it was across the WAN, it doesn't matter. There's just an IP connection with the RTP stream that actually goes on between the two phones. You can see that here in green. Let's move on. Cisco IP phones and SIP for Skinny. I was talking a little bit about that earlier. Skinny, SECP, is proprietary, and it's used for session signaling with the call manager between the phones. And right now it supports more features for the Cisco IP phones. This is because Cisco developed it internally, and they they've been a big part of developing SIP as well, but they started with Skinny. So, you know, generally speaking, a lot of the phones have better feature support for Skinny than they do SIP. However, SIP with every revision and new release of Call Manager, they keep adding more and more features to it. So SIP is an open standard. It will support third-party phones, but the third-party phones often lack the full feature set that's available with the Skinny-based IP phones. SIP are available on these models of Class B Cisco phones, so most of the newer phones support SIP. And like I was saying, the Call Manager actually is the proxy and registrar and redirect servers all in one. SIP trunks are an emerging and popular way to provide PSTN connectivity into a business. It's basically just a voice over IP line into the business, and it's provided by an Internet Telephony Service Provider, or ITSP. The ITSP maintains connections to the PSTN and provides the PST connectivity to the customer through a VoIP connection. SIP trunks require a Session Border Controller, or SBC, on the customer's network. In Cisco speak, this is known as a cube, and it can run as an iOS feature set on your router, but this is required to provide security and a number session termination and a number of other things from the SIP trunk that comes in here from the service provider to your network. That would be the SBC right there. SIP trunks. Here's a better example of a SIP trunk in a Cisco environment. So here's your service provider like CenturyLink or Comcast. They have their SIP servers, and they send, you get your trunks in through a voice over IP connection. Here's your gateway, and then you also have your Cisco cube. They also have firewalls set up. You don't necessarily need those. It just depends on your network, but you do need the cube. SIP trunks versus PRI. PRIs are TDM-based time division multiplex. This has pretty much been the standard for a number of years. It's a T1 with 23 B channels and 1 D channel for call signaling. SIP trunks, on the other hand, are voice over IP connections, so they're statistically multiplex instead of time division. So in conclusion, SIP's an open standard. It's growing in popularity. Cisco is actively involved in the design and implementation of SIP in their products. Cisco uses SIP exclusively now for a few of their products like IP Presence and the Cisco Unity Express are a few examples, but as they go forward, it looks like Cisco is going to be trying to go SIP with everything. But the other protocols are still there. In the end, we're just talking about signaling. So whether you decide to use H.323, MGCP, Skinny, or SIP for your call signaling between phones or gateways, you really just have to pick the ones that are going to help your organization the most and fit what you're trying to do. So in conclusion, it's just signaling. So hope you enjoyed it. Thanks again.